live? All right, well, welcome to episode 1 of Quarantine Math. I just want to let everybody know that I miss you. It's definitely going to be weird for the next several weeks until who knows when, but I'm here for you. I want to help you continue to grow as a mathematician. And I think that we'll be able to try some new things with digital learning that will allow people to learn at their own pace. And I think most important of all is really that you set yourself up with some kind of routine. Make sure you're getting some sunshine every day. Don't let your sleep schedule drift so that you're only awake at night, because the sunshine really will help you keep your spirits up. Make sure you're getting a little bit of exercise every day, even if that just means taking a walk around the block, and eat nutritious food so that your body has all the nutrients that it needs to keep your brain working at peak performance. So with that said, let me talk a little bit about what we're working on. This is the classwork packet. If you have it, great. I posted a PDF copy online so that you can see it if you don't have it. I think Sil was letting people come in to get stuff from their lockers before noon today and tomorrow on Thursday. But if you need a hard copy, you can contact Sil and she can mail you one too if you don't have access to a printer. But what I did was I took this packet and I found a website online that lets you enter your answers just as you would write them in the packet, so that I can see what you've done, Liz can see what you've done, Nikki can see what you've done, and then you also get instant feedback on whether you're right or wrong. The website is a little bit finicky, but we're not necessarily grading you on whether you got it right the first time or even the third time. There's a box in the bottom corner that lets you show the answer. So don't worry if you have to click that box and see what they think the answer is. Again, this is more about like classwork. So when you're practicing something new, you're going to make mistakes, you're going to have questions, and this is just a way for us to see your thinking when we're not right next to you in person. And everybody's doing math at different times in the day, so we're just trying things out to see how they work. So today's lesson is chapter 7, which is practice with rational bases. And the problems online look just like they do in the packet for the most part. There might be a few small typos here and there. I just wanted to talk about this word rational. So a rational number is basically all the numbers that you know right now. A rational number is a whole number like 1, a negative number like negative 2.5, 0 is rational, fractions are all rational like 4/7 or 2/5 or 1/3, 1/4. Any decimal that's repeating or terminating, like 0.33333333 is a rational number. Some examples of irrational numbers are pi, the square root of 2, and 10 to the 1/3 power. Anything that has a non-repeating, non-terminating decimal is an irrational number. So mathematicians break numbers up into these 2 big categories, and most of the numbers you've worked with so far up through your life are rational numbers, probably with about the exception of pi. So don't be thrown off by that word rational, but if you have questions and want to talk about it more, definitely contact us. Okay, so the exponent rules that we've used so far, I put them together on a few slides so you can see just exactly what it is that we've found, whether it was Aquila or Joaquin or Marcos. A lot of people found some patterns, and these rules apply not just to powers of 10, but to any number that you can raise to a power. So the first rule was that if we're multiplying 2 powers, like 4 to the 2nd power times 4 to the 3rd power, if you write that out, that means 4 times 4 times 4 times 4 times 4, and that's why it's 4 to the 5th power. And in general, x to a power times x to the n power times x to the m power is equal to x to the sum of n plus m, because that's how many times you're multiplying x. The next rule that we found was what happens when you raise a power to a power? You get superpowered. So again, writing out the expression shows you why this rule happens. If you have x to the second power and then raise that to the third power, that means you have x to the second power 3 times. And each x to the second power means, for example, in this case, 8 times 8. And then another 8 times 8. And then a third 8 times 8. 8 to the second power to the third power is then 8 to the sixth power. And here it is written just with variables to show that it works not just with 8s or 10s or 2s, but with any number that you raise to a power and then raise to another power. Then we looked at what happens if you're dividing powers. So here's the example with 3 to the fifth power divided by 3 to the second power. And we talked about how you can make 1, because anytime you divide a number by itself, in this case 3 divided by 3, that's equal to 1. This 3 divided by 3 is equal to 1. And so what's left in the numerator, because there were 5 3's being multiplied in the numerator and 2 3's being multiplied in the denominator, is you're left with 3 3's being multiplied. And so if you find the pattern, it's 3 to the fifth minus 2, or 3 to the third power. And again, this works not with just 3's, but with 2's and 10's and 15's. X to the n power divided by x to the m power will become x to the n minus m power. Then one of the more confusing results for a lot of students was a number raised to the 0 power. And people are thinking, oh, is it 0? Is it the number? Nope, it's always 1. And this example uses both the multiplication pattern that we found and the division pattern that we found to explain why. So what number, if I multiply it by no copies of x or no copies of 7, is like keeping it the same? Well, multiplying by 1 keeps something the same, and that's why any number to the 0 power, well, except for 0, is equal to 1. So this is a pattern that you can work out for yourself using the previous rules of multiplying exponents or dividing exponents and proving to yourself that it makes sense. And then finally, what happens when you have a number raised to a negative power? So because raising a number to a positive power is telling you that you're multiplying by that number that many times, right? If this is the base and this is the exponent, 9 to the positive 3 power would mean 9 times 9 times 9. But a negative power is the opposite of that. It means you're dividing by that number that many times. So here you would be taking 1 divided by 9, divided by 9, divided by 9, which is 1 divided by 9 to the third power. And so, there's a typo. And so, x to the negative n power is the same as 1 over x to the positive n power. It's the same as taking the reciprocal or flipping the numerator and the denominator of the original base and then writing it with the positive exponent. So here, 9 to the negative 3 becomes 1 over 9 to the positive 3 power. So I'll put these exponent rule slides after I fix the typo online so you can also reference them. They're also everywhere over the internet. If you were to Google exponent rules or laws of exponents or something like that, you'd find a ton of websites that are basically explaining the same concepts that I'm explaining to you, but obviously not as cool as I'm explaining it. Um, and so if you have questions, please definitely reach out to Liz, Nikki, and myself. We're happy to help you. We want to keep everybody learning a little bit of math every day, so make sure you're practicing somewhere in the 30 to 60-minute range. That, you know, includes the time that we would normally spend working on classwork together, plus the time you would spend working on homework together. It's all kind of homework now, but some of it's more designed to be like the teaching side of the math that we do in class, and some of it's designed to be more of the homework stuff that you would practice on your own. The three main tools that we'll be using, aside from the classwork packet site, is Khan Academy. And as you probably see now, that they have a ton of great lessons. And so sometimes I'll be posting myself with a lesson, and sometimes I'll be posting one of their videos or somewhere else's videos. And then IXL will help you develop that fluency where you get really familiar with the patterns so that they become second nature. But remember, it's not just memorizing the patterns, but really understanding why they make sense. If you forgot everything, could you figure it out just by trying some examples again and seeing like, oh, so 2 to the third times 2 to the fourth, how many 2's am I multiplying? And then realize, oh, that's Akila's pattern where it's 4 2's times 2 2's, and that makes 6 2's being multiplied together. Because again, above all else, math should make sense. That's all I've got for today. Again, hope you're all doing well, and we'll be talking to you soon. Are we all? All right, great.